Hi, welcome to the data handling tutorial. Today's tutorial is a long tutorial, so I do want you to press pause and press stop whenever you need to and do it over a few days as opposed to just doing it over one day. The reason I have decided to include all of this work in one tutorial is that all of the stats that you do at school level is interrelated. In terms of what you need to know, you need to be familiar with your grade 10 work on statistics, and I'd also strongly recommend you go through the section I've included called Using the Calculator. We will begin with a brief discussion on statistics. What is statistics? Why do we have to study statistics? There are two aspects of statistics. The first being that of data collection, and the second, data interpretation and prediction. The school work deals primarily with data collection. However, with all of the work that you will be doing, I want you to constantly think of the conclusions that you can draw out of the data sets that you are working with. When we look at the data collection aspect of statistics, we are mainly concerned with sample size and accuracy. When we look at sample size, we are looking at whether we have chosen the right amount or the right group. At the same time, we are also looking at what is the middle value, or what is the middle or the generalization that we can give to that sample size. When we look at accuracy, we are looking at how close to all of the values that we have, how close are they towards the middle. This may sound a little bit airy-fairy at the moment, but as we go through more statistics, you will see what I mean. I am going to use one example with which I am going to try to explain all of the different aspects of statistics at high school level. We are going to be looking at the mean, median, and mode, and then we are going to look at the standard deviation, and thereafter the box and whisker plot. Let us look at this example. You are studying the TV viewing habits of different people. You conduct a survey in which you interview 30 different people, and these are the results you obtain. So, what can we do about this data? What can we deduce from it? Let us have a look at that. Firstly, I am going to look for an average or a generalization I can give to this group. The reason for this is that there are millions of potential viewers out there. I've only got 30 people. I want to know more or less how much time does the average person spend watching television. This brings me onto a section of work called Measures of Central Tendency. The first measure of central tendency I'm going to be looking at is called the mean or the average. This measure is useful when we have a general population size and we are trying to work out a general average or a general central tendency. How do I get the mean? I add all of my different observations together and I divide it by the number of observations or the sample size. In this case, all of the values added together, or all of the hours spent watching television a day added together, comes to 70 divided by my 30 observations gives me 2.33. This means that on average, or rather it means that the average person spends 2.3 hours a day watching television. The next measure of central tendency I'm going to look at is called the median. Now please note that you do not need to work out the mean and the median and the mode for every single calculation. What you need to do is you need to look at your data and see whether the mean or the median is pertinent. The way I get the mean, I start off by ordering my numbers. What I mean by that is, look at the original data that I had. Notice something, it's in a very random order. And that makes sense because I interviewed people at random. So the first person gave me a result of 0 hours. The next person 3.5 hours, then 2 hours, then 2 hours, then 3 hours, then 4. It is all scattered, it is random. In order to get the median, I'm going to order my numbers. There are a number of different methods at your disposal in order to order the numbers. I'm not bothered which one you use as long as you order it properly. If I order this data set, it's going to give me the following. Now my median is the middle value, the exact middle number. I've got 30 values, so I'm going to be looking for the 15th or the 16th number. No, I'm going to be looking for the number in between the 15th and 16th numbers. If I take the first 15 values, think of it as if you're taking it on your left hand side, and the last 15 values on your right hand side, you are looking for what's exactly in the middle. In this case, my 15th value is 2, my 16th value is 2. That means that I'm looking for the number or the value in between those two. The value in between those two will equal 2, the 15th value plus the 16th value divided by 2. That means that our median or our middle number is 2 hours. The reason we had to do this, we had to add the two middle numbers together and divide it by 2, was because we had an even number of values. If we had an odd number of values, we'll just take the exact middle number. For example, if I've got these three values, let's just call it A, B, and C. B is the middle value. However, if I've got A, B, C, D, my middle value falls between B and C. So I'll have to add B and C together and divide it by 2. Notice something, our mean and our median were fairly close to each other. Our mean worked out to 2.33 and our median worked out to 2. The last measure of central tendency I have at my disposal is called the mode. Mode is only the most occurring number. Just a warning on mode, it can often be very misleading. In this case, thankfully, it was not. The mode or the most occurring number worked out to be 2. 2 occurred 6 times. All of the other numbers occurred 5 or 4 or 3 or 1 time or less. Now that I have my average or my generalization that I'm giving to the group of people, i.e. that they watch 2.3 hours of television a day, I'm going to test how accurate my data is. The way I'm going to do this, I'm going to use a tool called the standard deviation. Standard deviation measures how closely or how far apart all of my data are scattered around the mean. What I mean by that is that let's say my average worked out to be 5 and I had data sets ranging from 0 all the way up to 25. My standard deviation for that data set would be a lot higher than if my mean or my average was 5 and my data set ranged from 2 to 7 or 8. Let us look at how we get to the standard deviation. Remember that my mean or my average was 2.33 hours. To get to standard deviation, I'm going to use a table. Now please note, I am only using this table that I'm about to do to show you how we get to standard deviation. If you are using a scientific calculator, you are able to get to the standard deviation, in fact even the mean, by simply entering the data in. To find out how to do this, go to the section I've included called Using the Calculator. Reference to that is made in the workbook. The first column I'm going to draw into my table, I'm going to call it X. That's the amount of time people spend watching television. And I'm going to start it at 0 and move up in half-hour intervals all the way up to my maximum value of 6. So it'll go 0, 0.5, 1, 1.5 up till 6. My next column, I'm going to title it X minus X dash squared. That means that I'm going to take the value that I have, subtract from it my mean, which is X with a dash on top of it, to the power 2 or squared. The first one will be 5.43. How did I get to that? I said 0 minus the mean of 2.33, which gave me negative 2.33 squared is positive 5.43. The next one will be 0.5 minus 2.33 squared, which gives me 3.35. And I'll carry on doing that to get the following table. The next column I'm going to call frequency. Now frequency is the amount of times that each X value happened. Take a look at that data set that you have. The value X of 0 happened once, which means that its frequency is 1. 0.5 hours of viewing, that occurred twice, which means that its frequency is 2. And you can do the same for all of the values to get the following column. The last column in my table, I'm going to multiply my frequency by my second column, by X minus the mean of X squared. 1 times 5.43 will equal 5.43. 2 multiplied by 3.35 will give me 6.7. I'll do the same to all of the rows to get a final value of 13.47 at X value 6. What I'm now going to do is I'm going to add up everything in my last column. That will come to 63.70. Now to get my standard deviation. Standard deviation will equal the square root of the sum of my fourth column, 63.7, divided by my number of observations, which is 30. Square root of 63.7 divided by 30 will equal 1.46. That means that my standard deviation is 1.46. As I said earlier, a higher standard deviation means less accuracy, a lower standard deviation means greater accuracy, but it is all relative. We have to compare this to another standard deviation if we want to say whether one set of data is more accurate than the other. We don't have that in this case. All we do is we have this 1.46, but as a rule of thumb, 1.46 is not too far off. It is a fairly accurate number. As long as my standard deviation is not greater than my mean, that would be a total disaster of a data set. Now the standard deviation we have just looked at is a measure of how accurate our mean or our average is. That is, if we are using our mean or our average, as our measure of central tendency for our data set. If we are using our median as a measure of central tendency for our data set, how can we gauge its accuracy? We use a thing called the box and whisker plot. I'm going to run through very briefly how we can draw up a box and whisker plot for our example. Firstly, I'm going to start by bringing up our ordered data set. The reason I'm using the ordered data set is because in order to get our mean, we had to use an ordered data set, and our box and whisker plot requires us to break our data set down into quartiles or into quarters. Hence, we need it to be ordered. Now, a quartile, looking at that word quartile, means that we are looking at quarters. Box and whisker plot deals with the 4 quarters of our data set. Looking at this data set, in order to break it down into our quartiles, I'm going to start by putting down our median. Our median fell between 2 and 2, hence our median was 2. Now I need to break down the first half of our data set into the first and second quartile. The way I'm going to do this is the exact same way I found my median. I'm going to take my 15 values from 0 up till 2, and I'm going to find my middle number. My middle number will be my 8th number. That is 1. That is quartile, that is the end of quartile 1 and the start of quartile 2. Quartile 2 goes from 1 up till the median, which is 2. Quartile 3 will run from the median of 2 till 3. That is the range of quartile 3. And lastly, from 3 up till 6 is my range for quartile 4. The range that I'm speaking of is called the interquartile range. We are now going to sketch this on a graph. For my box and whisker plot, the axis that I'm going to use looks very similar to a number line. I'm going to start it at my first value of 0, and I'm going to run it for the entire first quartile range. That's from 0 up till 1. Make a second dash at 1. The next marking you make is at your median or at the end of the second quartile. Then at the end of your third quartile, then at the end of your fourth quartile. Notice we have quartile 1, quartile 2, quartile 3, and quartile 4. Now, from 1 till 3, basically your markings around the median. 2 is your median. Sketch it into a box. Then draw whiskers out to your last quartiles. Essentially, the box and whisker plot consists of your first quartile and your last quartile being the 2 outward whiskers, and your box consists of your entire interquartile range of quartile 2 and quartile 3 with your median sketched in the middle. Looking at this graph here, I can say that my data set is relatively accurate, or rather that my median chosen as 2 is a fairly accurate depiction of what is happening. I can also say that 6, the value of 6, and possibly even the 5s and 4s, or rather just the 2 5s, are outliers or lie far out in the data. Notice something, the first whisker is a very short one. The last whisker is a fairly long whisker. But my data set is fairly accurate because you'll notice my box is quite close. It ranges from 1 to 3 with my median being exactly in the middle. If my median were too far to the left or too far to the right, it would mean that my data set is slightly skewed. I want you to now have a go at the following examples. When you return, we'll go through it together. The first example I gave you to do read that there are shoe sizes given of 30 different athletes, and these are their shoe sizes. Before we go into any of the questions, please remember that I am not going to be doing long calculations in this example or in the next one. You have to have gone through the tutorial I've included called Using the Calculator, and in that tutorial there is a subsection that deals specifically with statistical data. Go through that, make sure you understand it before progressing with this tutorial. Now the data that I've given you, I've put it into numerical order, or rather into ascending order. I asked you firstly, which is a better tool to use to measure central tendency? Now think about this. This is shoe sizes. What's better to use, the mean or the median? If you calculated the mean, you are going to come to an answer of 8.7. If you calculated the median, well, median you don't really calculate, you take it more as being the middle number from our data that are in order, or rather from our ordered data. If there's 30 pieces of information or 30 results, we are going to look for the middlemost one. If it's in ascending order or descending order, I'm going to look for the middle one. Because there's 30, that's an even number, I'm going to be looking for the number between the 15th and 16th number or value. Looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This 15 form the first half of the results. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This 15 formed the lower half. That means that my median is going to go right in between, which is going to be 9 plus 9 over 2, which is 9. My median is 9. Now, which one is better to use, the mean or the median? With this data set, if we look at the mean is going to be 8.7, which we can round off to 9. However, that's not going to be very accurate. The median, on the other hand, gives us 9. This is the middlemost number, which is a more accurate measure of central tendency in this example. Now, there are different examples, each which have their better measure of central tendency. In fact, in this case, I actually think the other measure of central tendency, called the mode, would also be an accurate measure. So either the mode or the median would be a good measure of which is the middlemost number, which is the middlemost shoe size that is worn by these 30 athletes. Because we are looking at median, in order to test how accurate the median is, we are going to have to do a thing called a box and whisker plot. Now remember what I said earlier, that a box and whisker plot tests how accurate the median is, whereas standard deviation tests how accurate the mean is. If I do a box and whisker plot, I'm going to need my quartiles, my first quartile is going to be half of my first half of the data, which in this case is going to be 7 over here. Because there's 15 numbers in my top half of the data, it means that I'm going to have 7 bits of data. I'm going to have my quartile, 1 bit of information, and then another 7, and together 7 plus 1 plus 7 is 15. So I'm looking for that number. 1, 2, 3, 4, 5, 6, 7. That's my first quartile. And my next quartile is 1, 2, 3, 4, 5, 6, 7, which means that my middlemost number is 7. So my Q1, my first quartile, is at 7. My median is at 9. My second, or rather the end of my third quartile, 1, 2, 3, 4, 5, 6, 7. The next piece of data, 1, 2, 3, 4, 5, 6, 7. That means that 10 is my next data, and this forms my box. My whiskers are going to go all the way up to 13, which is over there, and it starts at 4, which is over there. Notice that my whiskers in this case, 4 to 7 is 3 units, 10 to 13 is also 3 units. My whiskers are very accurately drawn, or rather very accurate, which means that my interquartile range, quartile 2 and quartile 3, do fall exactly in the middle of the data. One slight problem though, notice that there's only 1 unit between 9 and 10 and 2 units between 7 and 9. That means that the median is slightly skewed to the right. And you can see that happening in that there are slightly more higher values, sizes 9, 10 and 9, 10, 11 and 12 than there are of the lower ones. Slightly more, not a lot. And that's what causes this to be skewed. But overall, a fairly accurate set of data. And that the box and whisker plot, all it has done is shown the level of accuracy of our median. Now granted, our median is slightly off, slightly skewed to the right, but that's not a problem. At the end of the day, it's still fairly accurate. Our box and whisker plot is not looking something like this, which would be very, very inaccurate. But it's all contextual. It depends on the data set that you are using. It also depends on what you are researching in order to determine whether the box and whisker plot shows how accurate it is. By the way, the more values we have, the more accurate our box and whisker plot shows our median to be. The next example that I gave you to do dealt with running times of those 30 athletes. And you will see that there are a whole range of different running times. But the most important thing I want you to keep in mind from that is that before you decide to go and order that data set, first look at it and see, do you need to? Now you only need to ever order a data set when you are working with median or quartiles. In this example, we are not going to work with quartiles because running times can more accurately be represented, or the measure of central tendency, the more accurate measure of central tendency of running times is definitely going to be the mean or the average. If we are dealing with mean, we are not going to be ordering our data. And look at that data set that's in front of you. It would be an absolute nightmare to sit and try and order that data set. Now imagine if we had 200 sets of data like that. Obviously on a computer it would do it automatically, but we are not looking for that. To get the mean, again I'll say this, use your calculator. Don't sit and do all these long fancy calculations. Your scientific calculator does have a statistics function. Use it. The mean from this data set of running times comes to 15.55 seconds. The standard deviation of this data set works out to be 1.64. Now the mean just told us what is the average running time. Let's just write that in seconds. The average running time was 15.55 seconds, or close to 16 seconds, 15.5 seconds. The reason we went to then calculate the standard deviation, you'll see in the workbook I asked you test its accuracy. The lower the standard deviation is, means the more accurate the mean is. As a rule of thumb, 66% of data